Hi guys, today we're going to talk about solubility curves. So we've been talking about properties of solutions, saturated, unsaturated solutions, aqueous systems, all that sort of stuff. And this is our solubility curves are graphical representations of all the things that we've been talking about. So you can see here is an example of a solubility curve graph. We have lots of different substances on here, all color-coded so you can see them. And we're following what's actually going on with them. So we see that this one, as temperature increases, we have temperature on our x-axis, the solubility of that substance also increases. We see that here again with our lead nitrate, our potassium nitrate. All of them really seem to have solubility curves that go up, 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 up. Salt or sodium chloride, not as drastic as the rest. And then we have this one down here, our cesium sulfate, that has one that goes down. So this means that as temperature increases, this substance actually gets less soluble. And the reason for that would be because it's probably a gas. So as you're heating it up, rather than these that are probably all solids, and as they heat up, those molecules and particles start to move faster and spread further apart, these ones are going to spread. It's already a gas, so they're moving faster, faster, faster. They don't want to stay in solution and they escape, which is why we see it flatten out too. So here are some types of questions that you'll see with solubility graphs. So we're going to do these ones together so that you're able to do the worksheet that I will show you in just a minute. So how much KCl will be dissolved at 10 degrees Celsius? So we find KCl right here, the dark blue line. And we find 10 degrees Celsius down here, temperature, and we're going to go up until we intersect with that blue line right about here, and we would say 30 grams of KCl could be dissolved at 10 degrees Celsius. So that's telling me that's the saturation point. It's not going to dissolve any more than that, so 30 grams of KCl would be my answer. How much NaNO3 will be dissolved at 10 degrees Celsius. So I find my sodium nitrate up here, NaNO3, and 10 degrees Celsius. Again, I want to follow that all the way up till I intersect with that line. And at 10 degrees Celsius, 80 grams of NaNO3 can be dissolved. And remember, this represents completely saturated. So that's how much the maximum that can be dissolved. If you kept adding more, it would just clump on the bottom. It can only dissolve up to that 80. So describe what happens to the solubility of cesium sulfate as temperature increases. So we talked about this a little bit already. As temperature increases, so following along the x-axis, the solubility is actually decreasing, and then it levels out. That's as much as it can be dissolved, and it's not going to dissolve anymore. So as temperature increases, less and less can be dissolved, and then it just totally flatlines. And then our last question, describe what happens to NaCl as temperature increases. So as temperature increases, here's our sodium chloride line, the lighter blue one. A little bit more, a little bit more, a little bit more can be dissolved. So as temperature increases, more and more NaCl can be dissolved or become soluble. So these questions are similar to what you're going to be asked to do on the worksheet. Here is the worksheet that you're going to be working on. So some different substances over here. You're going to treat this graph the same way. Again, temperatures on your X, solubilities on your Y. If 60 grams of our sodium sulfate is added to water at 20 degrees Celsius, so here's temperature. Our sodium sulfate is the yellow line. So if we add 60 grams in, so at 20 degrees Celsius, I'm going to follow 20 degrees Celsius. Here's 60 grams where that dash line is there. The solution is going to be, it's above the yellow line. So the solution is saturated. And you can just highlight it on there. The solution is saturated because it's above that line. And remember, this line represents how much can be dissolved, that complete saturation point. So if we put this much in, we're going to have up to about, looking at the yellow line, like 38 grams that will dissolve. And then the rest of it is just going to clump on the bottom. Remember, the only way that it's going to become super saturated is if we have a change in temperature where it's heated up and cooled down. That's not going to happen here. It doesn't say anything about that happening in this question. So your answer, saturated. Let's do number 2. If 60 grams of Na2 H2SO4, or sodium sulfate, is added at 50 degrees Celsius, the solution will be, so again, I'm following that yellow line, and if I'm adding to at 50 degrees Celsius, here's 50, I'm going to follow up, and at 60 grams, that looks like it's right at that saturation line. So again, my answer would be saturated. If it fell below the line, let's say it said we only put in 40 grams, it would be unsaturated. Remember, to be supersaturated, it has to say something about dissolving more, changing the temperature to get more dissolved, and that does not say that anywhere on here. So take your time and work on the rest of this worksheet, and then you can submit. You can do it right on here. You can do it on the doc and submit. You can take a picture of you handwriting it and to submit, whichever way works best for you.